Okay, guys, so our title for our notes is Empirical and Molecular Formulas, and our EQ is How do I tell the difference between an empirical and molecular formula is? So make sure that you've titled your paper this. So we have two vocabulary words here that we're going to look at. The first is an empirical formula. This is something that is reached experimentally Okay, it is the lowest ratio of elements in a compound. So I discover an unknown compound. My empirical formula is going to be basically a mass ratio. This is where that percent mass piece comes in that y'all learned about yesterday. I'm gonna be able to determine, well, I've got, for every one carbon, I've got 2 hydrogens and 1 oxygen based on mass. So we can use their masses to determine sort of what the ratio of elements in it is. This does not tell us the exact chemical structure. Okay, so it does not. Ooh, sorry guys, that's some terrible handwriting. Let me try that again. So it does not tell exact chemical structure. All right. The other thing that we have is what's called the molecular formula. And this is a multiple of the empirical formula that represents the actual chemical structure of the compound. Okay, so your molecular formula is some multiple of the empirical formula, but it's what represents the actual chemical structure of the compound. So, our essential question was, how do I tell the difference between the two? Well, let me give you a for instance. A nice simple one is H2O2, which we all know to be hydrogen peroxide because we used it a bunch in our last unit. Okay? So hydrogen peroxide would be H2O2. That is the molecular formula. Because in hydrogen peroxide, I have 2 oxygens bonded to 2 hydrogens. Okay? That's the actual molecule. That's how many there are. So I have 2 hydrogens, boom, boom, 2 hydrogens. I have 2 oxygens, boom, boom. Okay? It is not the empirical formula. The empirical formula for hydrogen peroxide would just be HO. Okay? So it's the same ratio, 2 to 2, 1 to 1. Okay? That's the same ratio. It's just fully reduced. Okay? But the difference is it does not represent the actual structure of hydrogen peroxide. It does not account for all the atoms that are actually present. It is the reduced ratio. Now, tricky thing is that they can be the same thing. For example, for water, H2O, that is the correct molecular formula. Because water really is 1 oxygen bonded to 2 hydrogen atoms. But that is also the empirical formula. because it cannot be reduced. There's no way to reduce a 2-to-1 ratio. That's the smallest ratio you can have. So they can be the same depending on what you have. So on your assignment for today, we're going to give you some pictures of some very complex molecules. And what I want you guys to do is figure out the molecular formula and then reduce that down to the empirical formula. So let's do one of those together. Okay, so here's the example off of your worksheet for today. So it's asking first for the molecular formula, and it says, hint, we write the symbols alphabetically. So the first one we want to start with is carbon, because C comes before H, which comes before O. So we're going to start with carbon, and we're just going to go up here and count them. We've got 1, 2 carbons, so this is C2. We're going to do hydrogen next, because that's the next alphabetically. We have 1, 2, 3, 4 of those, so that's H4. And then the last one we want to do is oxygen, and there's 1, 2 of those. So the molecular formula for this compound would be C2H4O2. Okay, so what's the biggest number that I can divide each subscript by? So looking at those little numbers, I have a 2, 4, 2. Well, they are all divisible by 2. So if I divide each of those numbers by 2, 2 carbons divided by 2 would be 1 carbon. 4 hydrogens divided by 2 would be 2 hydrogens. 2 oxygen divided by 2 would be 1 oxygen. So the empirical formula would be CH2O. All right, so what y'all are going to do is you are going to finish all of the practice problems, counting everything, okay? And you are going to answer all the questions and turn it in.